Continuing along with our discussion of Pythagoras' identities, which are very useful, as we've seen in pre-calc and much of trigonometry, what I want to do in this video is, instead of eliminating cosine of x and simplifying that down to 1, what I want to do in this video is take Pythagoras' original identity, sine squared of theta, plus cosine squared, that same angle theta, all that equal to 1, and what I want to do is divide out sine of squared of theta in this equation and see what we get from there. So let's just try this out. We could divide both of the sides of the equations by sine squared of theta. This breaks down to 1. Cosine squared of theta, we can just divide that by sine squared of theta. And 1 over sine squared of theta. So now, again, continuing along with our discussion, we've seen how we could just pull a square out of this and apply the power rule that we've seen in Algebra 1. This is just 1, we don't have to worry about that. This is the quotient, cosine of theta, over sine of theta, all squared. And this, again, is 1 over sine of theta, all squared. So now we could recognize, again, more reciprocal identities within this equation. We could simplify this down. If sine squared of theta, or just simply for that matter, sine of theta over cosine of theta is tangent, applying our intuition of reciprocal identities, then cosine of any angle theta over sine of any angle theta must be equal to cotangent that same angle theta. And I'll do a later video just discussing and sort of proving the reciprocal identities. They're not that hard to prove, but nonetheless I'll do it anyway. Now we have a square here, we can apply that. We know that, obviously, we have sine of theta, and we're dividing 1 by it. So that's just the reciprocal identity of sine of theta. That's going to be cosecant. It's written as CSC of theta. And again, we have a square here, so we can apply that. And now we have yet another way that we could arrange Pythagoras' identity, just using reciprocal identities and just simple intuition, to recognize another form that we could use to our benefit in our study and discussion of trigonometry.